Okay, question 7 from your quiz. Question 7 says the fifth root of 6 to the power of 6 to the power of 3 over 6 to the power of 9 to the power, or times 6 to the power of 5. So, according to BEDMAS, think of that fifth root like a bracket on the outside. If you guys remember, any root, whether it's square root or third root, can be written as a fraction for an exponent. So if I have something that looks like that, that's the exponent of a half. This would be the exponent of a third. So we're dealing with the fifth root of everything. So that's the exponent of 1/5. So I'm going to rewrite this question with two large brackets on the outside. I have 6 to the power of 6 to the power of 3 over 6 to the power of 9 times 6 to the power of 5. And our fifth root is going to be written as a fraction of a fifth on the outside. Then I'm going to deal with my brackets inside. So the one on top says 6 to the power of 3. That means we're multiplying those two. And on the bottom, I have 6 to the power of 9 times 6 to the power of 5. So I'm going to add those exponents. So 6 times 3 gives me 6 to the power of 18 over 9 plus 5, 6 to the power of 14, still to the root of 1/5, or sorry, the power of 1/5. Our bases are the same and they're dividing, so we're going to subtract our two exponents. So I now get 6, 18, subtract 14, to the power of a fifth. That gives me 6 to the power of 4, to the power of fifth. This is where many of you made a mistake. 6 to the power of 4. This is still a power of a power, so I'm going to multiply those two exponents. So I have 4 times 1/5. That's just going to give me 6 to the power of 4 over 5. That is your final answer for question number 7. Three marks. 3 marks. Okay, while you're copying that, I'm just going to write 8 beside it. The first one's quite straightforward. 8a, negative 345 to the power of 0. Anyone know what it is? 1. Anything to the power of 0 is 1. Anything. Next question. 6 to the power of negative 7 divided by 6 to the power of negative 5. I'm going to subtract my exponent. So I have 6, negative 7, subtract negative 5. I end up with 6 to the power of negative 2. But the question says I want positive exponents. So I need to turn this exponent positive, which means I'm going to invert this. I now get 1 over 6 to the power of positive 2. Good? 8c. 7 to the power of negative 3 to the power of negative 4 to the power of 2. These are all powers of the power, so I just need to multiply all 3 exponents by each other. My base stays the exact same, so I'm left with 7, negative 3 times negative 4 times 2. That's supposed to be, that's not a, there we go. That's it. Negative 3 times negative 4 is, anyone know? 12. 12 times 2, 24. 7 to the power of 24. Question D. 5 to the power of 3 to the power of 2 divided by 5 times 5 to the power of 7 That's a power. All to the power of negative 1. I'm going to deal with the top first. This is the power of a power, so again, we multiply those two. And down here, this is to the power of 1, and we're multiplying the bases, so we're going to add the exponents on the bottom of this fraction. So on top of this, 3 times 2 is 6, so I get 5 to the power of 6. 7 plus 1 is 8. I get 5 to the power of 8. All to the power of negative 1. Because I'm dividing again, I'm going to subtract exponents. So 6 subtract 8 is negative 2 to the power of negative 1. I multiply those two exponents. So here we subtracted just to give you an idea. Here we need to multiply. Negative 1 times negative 2, positive 2. 5 to the power of positive 2. E. X to the power of 3 times x to the power of negative 2 to the power of negative 4. X times x to the power of 11. Okay. Excuse me. This one gets confusing. Remember, according to BEDMAS, we do with brackets first. All of our brackets are simplified in here. So next step is exponents. So I actually have to multiply these two first before I add the exponents. Okay? Remember, exponents are first, then multiplication. So if I multiply negative 2 times negative 4, I'm going to get positive 8. So I get x to the power of 3 times x to the power of 8. And we'll do the top and the bottom at the same there. These are both bases multiplied by each other, so I'm going to add both the exponents. Remember, there's a 1 there. So I get x, and then 3 plus 8 is 11. So x to the power of 11 divided by 1 plus 11 is 12. X to the power of 12. And because both those exponents are divided, we're going to subtract. Sorry, both of the bases are divided. We're going to subtract exponents. So 11 minus 12 is x to the negative 1. But it says to keep them as positive, so I have to invert this. One over, yeah. Because it says to put it as a positive exponent, you have to do this last step. Okay, question number 9 says to evaluate. You guys have 4. Oh, I actually did number 9 already. We're going to skip it. Go back and watch that video where I did number 9. 9b. 27 to the power of 4 over 3. Okay. Now, remember a fraction. If I have 4 over 3, I can take the 3 from the bottom and make it a third root to the power of 4. And I just have to put the base inside the root. So our next step would be the third root of 27 to the power of 4. The third root of 27, if you put it in your calculator, is 3. 3 times itself 3 times is 27 to the power of 4. 3 to the power of 4, if you type it in your calculator, is 81. Okay. You guys are allowed to use calculators for the evaluate. I want you guys to show your steps, though. And C. (16) to 0.75. Now, I know many of you just typed this in your calculator and put the answer. I accepted it for the quiz. For your test, if you get a decimal, I want you to turn the decimal into a fraction. So 0.75 as a fraction is 75 over 100. And when you reduce that fraction, you get 3 over 4. So this becomes 16 to the power of 3 over 4. And just like before, we take the fourth root of a number and then the power of 3. So I take the fourth root of 16 I put it to the power of 3. 4 through to 16 is 2 to the power of 3. 2 to the power of 3 is 8. All right, gentlemen, we're going to take up our growth rate questions. We're going to try to get through all 4 before the end of class. It shouldn't take too long. Okay, first question says you're investing $2,000 at a growth rate of 2.5% over 20 years. Get rid of this. Our formula is, for number 1, P at N is equal to P-O-1. Now, we're talking about growth rate, so am I adding or subtracting? Adding. If we're talking about decay rate, what would be there? We would add a negative sign. So 1 plus R to the power of N. It says we start with $2,000. That's our P at O. So we replace P at O with $2,000. The growth rate is 2.5% as a decimal when we change it. To change that into a decimal, in case you don't know, just divide it by 100 in your calculator. You get 0.025. So this becomes 1 plus 0.025. And it says it's after 20 years, so that's the number of cycles to the exponent of 20. 2,000, 1 plus 1.025 when you add them, the power of 20. Can somebody help me out with 1.025 to the power of 20? 8? Okay. And then when I multiply 2,000 by that? 3,277. So, after 20 years, at 2.5%, his $2,000 has become $3,277. How much has he made in 20 years? Yes, we just subtract our new amount from what we started with. He made $1,277 in 20 years. It's not that great. Could have invested better. Okay, the second question. Go back up. How long until you have $10,000? So, $10,000. We'll rewrite our formula again. This time we're looking for N. We know P at N is $10,000. P at O is 2,000, and our growth rate, I'm just going to jump ahead. We already know it's 2.5%. And it's to the power of N. This is where it gets difficult. I need to isolate N, which we've done a little of this yesterday. First step is I'm going to bring 2,000 to the other side. Now, because this says 2,000 times this, when I bring it to the other side, it needs to be divided by 2,000. If I draw zeros, it's going to zoom in. So I just wrote straight lines. So, 10,000 divided by 2,000 equals 1.025 to the power of N. 10,000 by 2,000 is 5. 1.025 to the power of N. Now, I'm going to show you how to do this on a calculator. Okay, so we have our calculator up. Essentially, what I need to do is plug in values for our N. So I need to plug in values for my N. 1.025 to a certain exponent. And I need my answer to become 5. So from our previous answer, if you guys remember, after 20 years, he was only at 3,277. It's probably going to be a very large exponent. So I'm going to take 1.025 to the power, I'm going to try 50 years. I'm going to see if that takes me to the number 5. Remember, I'm trying to get it to equate to 5. So let's see, after 50 years, nope. Didn't make it. So, if N is 50, I only got 3.437. That's not even close to 5. Going to try a larger number, 1.025. 75. Ooh, 75 is too high. All right. Okay, we're going to go to 65. It's in between-ish. 1.025. Ooh, 4.97. That's very close. Okay, let's try 66. 1.025. Power of 66. I'm over. Okay, so we know somewhere between 65 years and 66 years, he will finally have $10,000 from $2,000. Is this a good investment? No. This is a terrible investment. He's not making very much money at all. But that's how we go about solving the number of periods. We have to estimate. Use information you know from before and estimate what you're going to get.
If we originally put in $2, about $10,000 out of 66.
Pay attention. Okay, question 3. If you had started with $1,000 and had $2,000 after 5 years, what is the growth rate? So that's pretty straightforward, this question. It's telling you exactly what you need to find. So our question 3, it says we start with 1,000 P at O, and we get to 2,000 P at N, and it was after 5 years. Our N is 5. So according to our formula, P at N equals PO 1 plus R to the N. Plug in these values. 2,000 for P at N, 1,000 for P at O, 1 plus R, power of 5. Okay. So first thing I'm going to do is I need to move this 1,000 to the other side. Again, because it's multiplied, it's going to become divided by 1,000. So I get 2,000 divide 1,000 is equal to 1 plus R to the power of 5. 2,000 by 1,000 is? 2. 1 plus R to the power of 5. Okay, this is the difficult part. To move that 5 over, I need to do the opposite of the power of 5. The opposite of the power of 5 is the root of 5. It's the 5th root of a number. There's 2 ways to put that in your calculator. You'll have something that looks like X, like this. You'd have to put the 5 in front of it. Or you could still put it to the power of 1/5 instead. The power of 1/5 is another way to find out on the calculator. So when I move the 5 to the other side, there's 2 options I'm going to get. I'm going to put both of them. I get either the 5th root of 2, if you have that option in your calculator, put it like that, or put 2 to the power of a 5th equals 1 plus R. Okay? You'll get the same answer. Doesn't matter what you put in. I'm going to put 2 to the power of 1 divided by 5, which is a 5th, equals we'll get 2 equals, sorry, not 2. Just solve that. 2 to the 5th is 1 point, we're going to say 1.5, we're going to round. Is equal to 1 plus R, same thing over here. I just need to bring the 1 to the other side of the equation. So we get 1, 1.5, subtract 1 equals R. It's going to be the same over here, so I'm just going to keep going. I get 0.15 is R. So as a percentage, what is that? That stands for 15%. That means he had a 15% growth rate. R was 15%. Finally, I know you're very restless. Question 4. If you have a growth rate of 5% after 10 years and you make $1 million, what did you start with? P at N is $2 million. Your growth rate, it's 1 million. Growth rate was 5%. After how many years? 10, right? N is 10 years. So our formula again, P at N equals P at O, 1 plus R to the power of N. Plug in 1 million for our P at N. P at O is what we're looking for. Growth rate of 5% is 0.05 to the power of 10. So I get 1 million equals P at O, 1.05 to the power of 10. 1.05 to the power of 10 equals 1.62. So we have 1 million equals P at O, 1.62889. Yes. So to bring that to the other side, because I'm trying to isolate P at O, I need to divide 1 million by that number. Can you move? 1.62889. P at O. So 1 million divided by our answer from before. There it is. What was it for? And a quarter, 25 cents. So, if you invested $613,000, or 6,130, well, 601, oh gosh, there we go. Thank you for saying it for me. If you invest that much, you'll have $1 million after 10 years at 5%. That was difficult. Yeah, it's not the greatest investment.